Right, hello. So today I'm going to be looking through, this is one of the sample papers for the MEI, the new A level, and this is the maths and mechanics paper. So there's going to be two AS level papers. One's going to be maths and mechanics, and one's is maths and statistics. And at the moment, this is one of the only papers we've already got to give us an idea of what the new A level is going to look like. Okay, so question one. So this is quite a simple kind of algebraic manipulation question. So if we look what's going on here, we've got to, first thing is we've got to cube everything in those first brackets. So 2 cubed is 8, x squared cubed is going to be x to the 6, y cubed is y cubed, and that's being multiplied by 4x cubed y to the 5 over 2xy to the 10. So now we can probably deal with the numerator. So we can do 8 times 4 is 32. X to the 6 times x cubed is going to be x to the 9. So this is just using indices laws. Y cubed times y to the 5 is y to the 8. And that's still over 2xy to the 10. And then essentially we can just start cancelling things down. So if we cancel down the 32 and the 2 to a 16, we can cancel one of the x's out. So that will become x to the 8. And we can cancel y to the 8 from top and the bottom. So y to the 10 is going to become y squared, and y to the 8 is going to disappear. So if we tidy that up and see what we've got 16 x to the 8 over y squared. Okay. Question 2. So this is a binomial expansion question. So here, rather than getting us to work out every single term, it's just asking us for one specific term, so x to the 4. Also, remember the word coefficient means it's just the number before, so we don't need to put down x to the 4 after it. So the way to do this is to look at this expansion and pinpoint the term that's going to give you an x to the 4. So we're going to have powers of x to the power of something and times by minus 3 to the power of something. And we know the coefficient from the binomial expansion is going to be 5c something. So we're going to want to put a number to the power of x that's going to give us x to the 4. Now obviously in this case that's going to be a 4. So that must mean the power of minus 3 must be 1 because these powers need to add to 5. And then it's going to be 5c, and then here you can put either 4 or 1. So because it's symmetrical, it will give you the same answer. So 5c4 is 5, and then we've got times x to the 4 times minus 3 to the 1. So that's minus 15 x to the 4, but you need to make sure your answer will be minus 15. So if we look at the mark scheme for those two questions, you've got two different answers there. So this is the one I put, but you could have put it as y to the minus 2. Next one, minus 15, that's 3 marks. So you get 2 marks for getting 15, or them seeing something like this, and 1 mark if they see something like 1 row of Pascal's triangle. Okay, question 3. So this is our first kind of mechanics question on the paper. So we've got a particle of weight 8 newtons on a rough horizontal table. It's being pulled by a horizontal force of 10 newtons, and it's in equilibrium. So what information given in the question tells you that forces shown in figure 3 cannot be the only forces acting on the particle? Well, the thing we need to say here is the fact that they've told us it's in equilibrium. So that must mean these can't be the only forces acting on it because they don't balance out to keep the object in place. So we'll look at the mark scheme for that in a second. Part 2, the only other forces acting on the particle are due to the particle being on the table. State the types of these forces and their magnitudes. So we know it's got to be in vertical equilibrium. So there's got to be this force going up here. So that's going to be the normal reaction force to the table. So we know that's going to be a normal reaction. And it's got to be the same size as the force going down, so it'd be 8 newtons. We also have to have the same thing here going to the right, and that's going to have to be a frictional force. So we've got a force going, and then if there's no other forces acting, the only thing can be friction, and we know friction's there because it says it's a rough horizontal table. So we'll have a friction of 10 newtons. And you know it's not going to be too much work because it's just 2 marks. Okay, let's quickly get out to the mark scheme. So there you can have, basically, as long as you put the particles in equilibrium, and they'll accept, you might have seen that there's it's a rough surface. That's another piece of information that tells you there's another force going on. And then friction 10 newtons and normal reaction 8 newtons. Okay, so question 4. So express x squared plus 4 plus 7 in this form. So that means we're going to have to do completing the square. So there's different ways people do this. Some people will expand the right-hand side and equate coefficients. What I prefer to do is to write down x plus something squared that I know will give me x squared plus 4x. And then I know that if I expand that out, I'll get a plus 4. So to cancel it, I'm going to minus 4. And then we've still got our plus 7. So all of this here is equal to x squared plus 4x. And then if we add them up, we've got plus 3. Okay, part 2. Explain why the minimum point on the curve y equals x plus b squared plus c occurs when x equals minus b. So what we need to do is think about this equation and think about why do we get a minimum when x is minus b. Now if we look at what's going on here, we can see the only thing we can change as an input is x. So we've got to try and think what would give us the lowest input there. Now if we look what's happening to x, we're adding b and then it's being squared. Now if it's being squared, remember squaring can only give a positive number. The lowest you can get if you square something is 0, and that's if the thing you're squaring is 0. So if we want to make the thing inside the bracket 0, x will have to be minus b. Now that took me quite a long time to say, and this is only 1 mark, so you're not going to have to write that all down. So let's see what they expect from you. Okay, so part 1 is just 1 mark for each number. And they want, since x plus b all squared is greater than or equal to 0, the minimum value occurs when the expression in the bracket is 0. So that implies that x must be minus b. So I think that's quite a lot of words for 1 mark for a maths exam anyway. Okay, question 5. A particle P moves on a straight line that contains the point O at time t seconds. So they're giving us the displacement of this particle. So we've got an equation to tell us how far away from the origin the particle is. So it says determine the times when the particle has 0 velocity. Now what we need to realise here is they've given us the displacement, we want velocity. So to get velocity from displacement, we have to differentiate it. So we're going to have to do ds by dt, and then so t cubed is going to become 3t squared. Minus 3t squared is going to be minus 6t, and the 3 will disappear. And then we know that's got to equal 0 because we want 0 velocity. All right, so now if we try and solve this equation, we can actually just factorise out 3t, and then we'll have t minus 2 in the brackets. So either t equals 0 from there, or t equals 2 from that bracket. Okay, find the distances of P from O when it has 0 velocity. So what we need to do now is sub these numbers into S and see what we get. So when t equals 0, if we sub it in, we've got S equals 0 cubed plus, minus even, not that it makes a difference, minus 3 times 0 squared plus 3. So the answer is just 3. Now remember, they've said distance, they haven't said displacement. So we need to kind of leave off whether they're positive or negative. So our answer here is going to be 3 meters. So when t equals 2, we've got to do the same again. So S is going to equal 2 cubed minus 3 times 2 squared plus 3. So that's obviously, use a calculator for this. 8 minus 12 plus 3 is minus 1. So it's going to be minus 1 meters. But like I said before, it's a distance, so it's just going to be 1 meter. So let's just have a look at the mark scheme. Right, so a mark for differentiating, a mark just for setting it to 0, and then a mark for solving. And then you get 3 meters, 1 meter. and yeah, so you do need to put that as 1 meter. Okay, so question 6. The 2 points A and B are position vectors. A equals I minus 3j, B equals 4i plus 4j. Another point C lies on the line y equals 1. And it says the two line segments AC and BC are equal, determine the position vector of C. So remember, position vectors are kind of like coordinates. It's the vector that takes us from the origin to the coordinate. So I'd say we're best off seeing if we can draw a little diagram of what's going on to start with. So first of all, the point A has got a position vector I minus 3j. That means it's gone 1 to the right and 3 down, so it's going to be about here. And I prefer to write that as a column vector, so that i's and j's just get very confusing to me. B is at 4 plus 3j, so it's here. And then we've got another point C, which is on the line y equals 1. So we know it's somewhere along this line. It has y coordinate 1, but we don't know the x coordinate. What we do know is the distance from A to C and the distance from B to C are equal. So I reckon it looks like it's going to be around about here, just because it looks to me like that's around about where those lines would be equal. It doesn't really matter, this is just for my sketch. So now I do know about C that its y coordinate be 1. I'm just going to call its x coordinate x, and then we'll see if we can come up with some equations to help us find x. So now the information we know is the distance from A to C and B to C are equal. So let's see if we can write down what those two distances are. Now I'm going to use the formula for distance, which is y2 minus y1 squared plus x2 minus x1 squared. So I know that if I make the second coordinate the coordinate C and the first coordinate, let's say the coordinate of A to start with, this is going to be y2 minus y1 squared, so it's going to be 1 minus 3 squared plus, and then x2 minus x1 is going to be x minus 1 squared. Okay. Then if we do the same thing for BC, we're going to have 1 minus 3 squared, so that 3 comes from the y coordinate of B, plus now we're going to have x minus 4 squared. Okay, so what we can do now is imagine making these two expressions equal to each other, and I'm just going to also pretend that I've squared both of them to make my life a bit easier. So AC equals BC. So 1 minus 3 squared for the left-hand side, that's going to be 4 squared, which is 16, and then I've got plus this. And that's got to equal 1 minus 3 squared, which is minus 2 squared, which is 4, plus x minus 4 squared. So now I'm going to have to expand out these brackets. And that's going to equal 4 plus x squared minus 8x plus 16. Okay, so let's group everything together and see what we can do. Now, first off, I can see I've got a 16 on both sides I can cancel. An x squared on both sides I can cancel. So if I add 8x, I'm going to have 6x equals, so if I throw the plus 1 on the left over to the right, I'll have minus 3. So x is minus a half. So now my position vector of C is going to equal, so I know it's going to be minus a half I, because I know that x is minus a half, plus, and I know it's going to be 1j, because we know it lies on the line y equals 1. Okay. So what have they done? They've done it a very different way. So what we've done here is this alternative method, where we've supposed C as pi plus j, what we did was call it x. And then they've expressed the vector AC and BC similar way that we did there, and got to p as a half, and we got x as a half. Now what they've done is found that the midpoint of AB is at 5, 2, 0. So they found the midpoint of the 2 points. So let's say it looks something like that. the gradient of the perpendicular is -1/2. So then they've found the perpendicular bisector. And what they've essentially done is the perpendicular bisector will be all of the points where the distance between A and B is the same, and then they've just substituted in 1 because we know the y coordinate is 1. So effectively, if we go back to our diagram, what they've done is found the equation of this line and then substituted in 1. So on this green line are all the points which are equidistant between A and B. All right. Okay, question 7. A car is usually driven along the whole of a 5-kilometre stretch of road at a constant speed of 25 metres per second. On one occasion, during a period of 50 seconds, the speed of the car is shown by the speed time graph. The rest of the 5 kilometres is travelled at 25 metres per second. How much more time than usual did the journey take on this occasion? Show your working clearly. Okay, so what I think we're going to have to do first of all is try and see how long it usually takes to do this journey. So we're going to travel 5,000 meters at 25 meters per second. So if we do time as distance over speed, so we're going to do 5,000 divided by 25, so that's going to take 200 seconds. So what we need to do now is see how long it takes us when we've been slowed down by this amount. And so, yeah, then we can compare those and come up with the difference in time. So now we know the majority of the journey is done at 25 meters per second, but there's been this slowdown here. So let's see how much distance is covered in this time. Now what you need to know is to find displacement from a speed time graph, we need to find the area underneath the graph. So for this 50-second stretch, let's see if we can find the area under the graph. So different ways you could do this. I'm going to split it up into 2 trapeziums and a rectangle. So this first trapezium, we're going to have to do half times the sum of the parallel sides, which are 25 and 10, so that's 35, times the distance between them, which is 20. So that's going to be 350 meters. Okay, this one's quite simple because it's just 20 times 10, so that's 200 meters. And this one is similar to the one above, half times 10 plus 25, which is 35, times 10. So I think that's probably going to be 175. Let's just double check. Yeah. So we know for this stretch of the journey, we've done a total of 175 plus 200 plus 350 meters. So that's done 725 meters, which means the remainder of the journey, we've got to do. So if we take off, what did I just say, 725. We're going to have to do 4,000, I'm just going to double check this because I don't trust myself, 4,275 meters. But this we are going to be doing at 25 meters per second. So we can do that 4,275 divided by 25, which is 171 seconds. So the kind of part of the journey which is going normally, we're doing in 171 seconds, but we were slowed down for those 50 seconds. So in total, that's 221 seconds. So our answer is going to be the difference between 200 seconds and 221 seconds. So just the 21 seconds. Okay, so if we look at a couple of different methods, find how much less distance travelled in. So this is, I think, again, I've done the alternative method. Find the distance travelled in the 50 seconds and do all that. They've done it slightly differently. Find how much less distance travelled in the 50 seconds. So the distance less is the area of a trapezium. So that's going to be when we look at that trapezium, this trapezium here, so that's how much less distance they've travelled in those 50 seconds. So they found that's 525 metres. So that means that we're going to have to make that up at 25 metres per second. So the extra time is 21 seconds. So their way of doing it was probably more direct than ours. Okay. Right, question 8. A circle has equation, blah, blah, blah. Write down the radius and the coordinates of the centre. So you need to know that all circle equations look like x minus the x coordinate of the centre squared plus y minus the y coordinate of the centre squared, and that equals a radius squared. So the radius is going to be 5 because we've got to square root it. The coordinate of the centre is going to be 2 minus 3. Right, find an exact form, the coordinates of intersection of the circle with the y-axis. Now you need to know if you hit the y-axis, that means x is 0. So let's sub x is 0 into the equation. So we're going to have 0 minus 2 squared plus y plus 3 squared equals 25. And then we've got to solve this. So minus 2 squared is 4 plus y squared plus 6y plus 9 equals 25. So we've got a quadratic, as you'd expect. And we're going to have y squared plus 6y. So we've got 4 plus 9, which is 13, minus 25, so minus 12 equals 0. Now, it says in exact form, which says to me we're not going to find nice answers here. So I'm going to jump straight to doing the quadratic formula. So I've got minus b plus or minus the square root of b squared minus 4ac all over 2a. So that's minus 6 plus or minus, so I've got 36 plus 48, which is 84, all over 2. And I reckon we can cancel down that root 84. So you've got to try and think, well, let's just do it the side to start. So I think we can take out a 4, and we'll have root 21. So that's 2 root 21. So we've got minus 6 plus or minus 2 root 21 all over 2. So that's minus 3 plus or minus root 21. Now we do have to write down the coordinates. So we know that y is 0. So it's going to be minus 3 plus root 21, 0. And minus 3 minus root 21, 0. Okay, let's look at the mark scheme so far. So part 1 is pretty bog standards, and then part 2, it's 1 for subbing x is 0 and rearranging, 1 for getting the roots, and 1 for getting the answers. Probably a simpler way is if we got it like this, we could have square rooted both sides instead of having to go into the formula, which probably would have been a little bit easier. Okay, so next bit, we've got, bear with me, show that 1, 2 lies outside the circle. Now, if we think about how we define these circle equations, it's all the points which have got a distance of 5 away from the centre. So let's see if we can find the kind of distance away from the centre of that point 1, 2. So we're finding the distance between 2 minus 3 and 1, 2. So we're going to use that distance formula we used earlier. So the distance is going to be y2 minus y1 squared plus x2 minus x1 squared. So that's 2 minus minus 3 squared is going to be 25. Pardon me. 1 minus 2 squared is 1. So we've got root 26. So we know the distance to the point is root 26, which is bigger than 5. So we probably ought to say something there to say which is greater than 5. So again, I've done it a slightly alternative way. They've subbed the point into the circle and shown this is more than 25, so outside the circle. So essentially, if you substitute the point into the left-hand side of the equation, you'll get 26, which is bigger than 25, so you can justify it's outside the circle. That's what I did. Right, okay, part 4. So the point -1, 1 lies on the circle. So let's see if we can draw a sketch of our circle, which has got centre 2, -3, and our point -1, 1 is here. So our circle looks, that's not very good, is it? Something like that. And we're trying to find the equation of the tangent to the circle here. Okay. Now what you've got to do with all of these is realise that the tangent is perpendicular to the radius. So this is the point 2, -3. This is the point -1, 1. So first off, let's see if we can find the gradient of the radius. So if we have a look, it's going across 3 and down 4. So the gradient is -4/3 because it's sloping downwards. Yeah. So that must mean the gradient of the one perpendicular to it you have to kind of flip it and change the sign, will be 3/4. So we know the gradient of our line is 3/4 and the point on it is -1, 1. So now we can just use y minus y1 equals m x minus x1 to solve. So we've got y minus 1 equals 3/4 x minus -1, so +1. And actually, I suppose we should really expand and rearrange it, but it hasn't said it wants it in any specific form. But we're good mathematicians, so we want to put it in a nice form. So 3/4 plus 1 will be 7/4. So probably 4y equals 3x plus 7 would be nicer, which is what they've got there. So one for finding the gradient from the centre to the point, one for saying the flipping it and changing the sign, one for giving the equation of the tangent, and then finally for the equation. So the OE means or equivalent, so you could put whatever you like there. Okay, so now question 9. A biologist is investigating the growth of bacteria in a piece of bread. He believes the number n of bacteria after t hours may be modelled by this relationship, where n and k are constants. Show that according to the model, the graph of log n against t is a straight line. Okay. Give in terms of a and k the gradient of the line, the intercepts on the axis. So the model they've got is n equals a times 2 to the kt. So what we're going to have to do is log both sides. So log n equals log of a times 2 to the kt. And then we want to break up this right-hand side using log rules. So we know when we've got log of two things times together, then we can split it up and make it log of two things added together. And then where you've got a power in the log, like we've got here, that drops to the front of the logarithm. So we know that log n equals log a plus kt log 2. Right, so now we need to think about y equals mx plus c, and how does this match up? So first off, our kind of x and y are really t and log n. All right, and they've said they're talking about plotting log n against c, so we know that would be y and that would be t. Now, the number on its own is this log a here, so we know the y-intercept must be log a, and the number that's timesing x is this k and this log 2, so we know the gradient is k log 2. Okay, so that's part 1. So let's leave that there. I'm just going to get rid of this. So the biologist measures the number of bacteria at regular intervals over 22 hours and plots a graph of log n against t. He finds the graph is approximately a straight line with gradient 0.2 and crosses the vertical axis at 2. So we know log a equals 2 and k log 2 equals 0.2. So what we're going to have to do is first off, to solve this, a is going to equal, now we're going to undo a log, you have to put both sides to the power of whatever your log base is. So log without any labels, or they have labelled it as log base 10. So we're going to have to do 10 squared. So we know A is 100. And then to find K, we're going to have to do 0.2 divided by log 2, which is so 0.66438. So you get 1 mark for each there. There's not a lot more to it than that there. So we'll say K is 0.66. Okay. Use the model to predict the number of bacteria after 24 hours. So at this stage, you can just substitute A and K into the equation. So now we know instead of N equals A times 2 to the KT, it's going to be 100 times 2 to the power of 0.66T. Okay, so after 24 hours, you've got to make T equal 24 and see what you get. So what you should get is 6,300,000. So you're allowed answers in the range 5,860,000 up to 6,400,000, and so follow through your A and your K. I would probably leave it to a couple of significant figures, and I'd say 2 is good in this situation because it's not a very accurate. We're not given readings any more accurate than 2 significant figures anyway. So final one, give a reason why the model may not be appropriate for large values of T. Well, if we look at the situation, it's bacteria growing on a piece of bread, and you'd assume the bread has limits. It's not an infinite piece of bread going off forever. So something like the piece of bread may not be sufficient to support the number of bacteria, or bacterial growth may obey different rules for large values of T. So they don't really want anything too biological there. Okay, 10, part 1. So first off, sketch the graph of 1 over x plus a, where a is a positive constant. So, and they want us to state the equations of any horizontal and vertical asymptotes, give the coordinates of any point where the graph crosses the x-axis. Now, hopefully you know that the graph of 1 over x looks like that, which has got asymptotes at x equals 0 and y equals 0. Now, if we add a, that means it's going to move up by a units. So now that horizontal asymptote that was at 0 is now going to be at y equals a, but the one at x equals 0 hasn't moved. So it's still on the y-axis, so it's going to look like that. Now we also need to know where it crosses the axes. Now we see it only crosses the x-axis, which is where y equals 0. So to find that, we need to set y to 0. So we're going to have 1 over x equals, minus a. So x will equal minus 1 over a. And that's where it's going to cross the x-axis. So to get the marks there, correct shapes of y equals 1 over x moved upwards gets you a mark. Crossing at minus 1 over a gets you another mark. And asymptotes there gets you in that last 2 marks. So you need to make sure you state those as well. Okay, find the equation of the normal to the curve at the point where x equals 2. So this has really now become a differential equation. Remember, this is finding, like the tangent, but it's got to be 90 degrees to the curve at that point. So, first thing we're going to want to do is differentiate our function. So this is really, if we want to differentiate it, let's think of 1 over x as x to the minus 1. So x to the minus 1, we have to drop the power to the front, so it'll be minus 1 times x, and then take 1 away from the power, say to the minus 2, and the 2 will disappear. And we want to know what's the gradient when x equals 2. So when x equals 2, we're going to have minus 2 to the minus 2, which is minus a quarter. Now we're not. This would be the gradient of the tangent at that point. We don't want the tangent though. We want the normal, which is at 90 degrees. So we know that the gradient will be, if we flip a quarter, we get 4, but it's going to be plus. So the gradient will be 4. Now we know x is 2. What we don't know is the y coordinate. So to do that, let's sub in 2 into here. So we'll have a half plus 2 which is 2.5 or 5/2 or 2.5, whichever you like. I prefer fractions, so I'm going to leave it like that. And so we've got y, using y minus y1 equals mx minus x1 again. We've got y minus 5/2 equals mx minus x1. So y minus 5/2 equals 4x minus 8. So y will equal 4x, and that's going to be minus 16, minus 11/2, or minus 5.5 to people who like decimals. So let's see how we're getting on so far. They've just multiplied everything by 2 to get rid of that fraction. So you get a mark for differentiating, a mark for getting minus a quarter, a mark for then saying that's going to be perpendicular, so it's 4, a mark for putting it into this, and a mark for getting to the final equation. Okay, and now it wants to know where this normal meets the curve again. Okay, so now we want to know, when does y equals 4x minus 11/12, when does it meet y equals 1/x plus 2? So we're going to have to set these two functions equal to each other. So we've got 4x minus 11/2 equals 1/x plus 2, just because we're looking for where these things intersect. So what I'm going to do to start is multiply everything by x. So I've got 4x squared minus 11/2x equals 1 plus 2x. Now, because I don't like that fraction, I'm going to times everything by 2 to get rid of it. And it looks like we've got another quadratic. So let's get everything over to the left-hand side. So we'll have 8x squared minus 15x minus 2 equals 0. And does that look like it'll factorise? So we might have to use the quadratic formula because we can't divide anything here. I think I'm going to jump straight into the quadratic formula here. There's nothing about exact coordinates. Well, actually, we know one of the intersections is going to be 2 because we already know this is the normal where it is 2. So I reckon we know one of the brackets is going to be x minus 2. So the other bracket must have to be 8x to get the 8x squared and plus 1 to get the minus 2. Now, does that make sense? 8x, we imagine multiplying out 8x squared minus 16x plus x minus 2. Good. So we get x equals 2 from here, which we already knew, and x equals minus an eighth from here, which is, if you'd done the quadratic formula, that's what you would have arrived at anyway. The only thing we need to do now is find the corresponding y coordinate. So I'm going to sub that into y equals 1/x plus 2. So we're going to have 1 over minus an eighth plus 2, which is minus 8 plus 2, which is minus 6. So our coordinate is minus an eighth minus 6. Let's hope and pray that's right. And yeah, there we go. So a mark, they've done it by substitution, but they've still come to the same quadratic, and then it's a mark for getting to the full rest of the coordinate. Okay. Question 11. In this question, you must show detailed reasoning. This essentially means you can't just write down the answer. You can't just put it all into your calculator. So it says determine the values of k for which these two graphs intersect. Now, for questions like this, what I'd recommend doing is, let's say we're imagining finding the points of intersection and then see what happens. So what we do in that case is we'd make 2x squared minus kx equal x squared minus k. So it looks like a quadratic here, so let's get everything over to the left-hand side. So if we take away x squared, we'll just have x squared, and we'll have minus kx plus k equals 0. Now, what would we do in this situation? We'd try and find, to find points of intersection, we'd essentially try and solve this equation. Now, if we're trying to determine when they intersect, that means this equation must have solutions. In other words, the determinant, the discriminant must have to be bigger than or equal to 0. So if it equals 0, it means they hit at one point. If it's greater than or equal to 0, we know they'll have two solutions. If it was less than 0, they wouldn't have any solutions, i.e. the curves wouldn't intersect. So minus b squared is going to be, sorry, not minus b squared, just b squared, it's going to be minus k squared minus 4 times a times c. So we've got k squared minus 4k is greater than or equal to 0. Now, so this is a quadratic inequality. So what I would do is look at where does it equal 0, which we can solve quite easily. We can see that's when k equals 0 or k equals 4, and then try and sketch what it would look like. So if we draw a quick sketch, it's going to look, that's awful, it's going to look like that. It's going to cross at 0 and 4, and we want to know when is it greater than that. So that's going to be for x values which are less than or equal to 0, so k is less than or equal to 0, or greater than 4, so k is greater than or equal to 4. So looking at the mark scheme, you get quite a lot of marks even if you don't really know what you're doing. So you get a mark for equating them, a mark for turning them into a quadratic, and a mark for thinking about the discriminant. So you've already got half the marks, and then the last 3 marks are for solving the quadratic inequality. Okay, question 12, last question. A small package hangs from a balloon by means of a light inelastic string. The string is always vertical. The mass of the package is 15 kilograms. Catherine initially models the situation by assuming there is no air resistance to the motion of the package. Use Catherine's model to calculate the tension in the string if. So what I'm going to do is start off by drawing a diagram of the situation. So it's got a mass of 15 kilograms, so it's going to have weight going down 15g, and then there's tension in the string. Okay, nothing else going on. She said there's no air resistance. So we want to know the tension if the package is held at rest. So if it's held at rest, that must mean that the tension and the 15g cancel out. So T will equal 15g. Remember, G is in maths exams 9.8. I think it's something slightly different in physics exams. So that's 147 newtons. Part 2, the package is initially at rest and accelerating upwards at 2 meters per second squared. So if it's accelerating upwards, then Newton's second law comes into play, which means the resultant force is equal to mass times acceleration. So our resultant force going upwards, we've got the tension going upwards and the weight pulling backwards, and that equals mass times acceleration. So we know T minus 147 equals 30. So T will equal 177 newtons. Okay, part 3. The package is moving downwards at 3 meters per second and accelerating upwards at 2 meters per second. Right, now, the fact that it's moving actually doesn't have any bearing on the question. All that matters is the acceleration. So actually the answers for part 2 and 3 are going to be the same. It's going to be 177 newtons again, because the only thing that affects the force is the acceleration, not the speed. Okay. Catherine now carries out an experiment to find the magnitude of the air resistance on the package when it is moving. At any time when the package is accelerating downwards at 1.5, she finds the tension is 140. Calculate the magnitude of the air resistance at that time. Give, with a reason, the direction of motion of the package. Okay. So now we know it's accelerating downwards at 1.5 meters per second. Now that doesn't mean it's moving downwards. All that means is we know so if it's moving up, it would mean it'd be slowing down, going downwards. Now the reason this is a bit confusing is because air resistance opposes motion, i.e. if the package is going down, air resistance is going up. If the package is going up, air resistance is going down. So what I'm going to do, I'm just going to assume the package is travelling downwards, and I'm going to put the air resistance, which I'm going to call R, going down. Now this is fine because if we get a negative answer, then we just know the air resistance is going in the opposite direction, and that will give us a bit of information about the direction of motion. Okay. Now we've been told, now we know that T is they told us it was now 140 newtons. So we know this is 140. Okay, so we can do another Newton's second law equation to see if we can work out what R must be. So what I'm going to do now is I'm going to do the resultant force going downwards equals mass times acceleration. So the resultant force going down is 15g plus R, but now minus 140, because that's going the other way, and that's got to equal mass times acceleration. So if we solve this, we've got to do 15 times 1.5, so that's 22.5, plus 140, minus the 15g, which I think was 147, so that's 15.5 newtons. Now, because that's positive, it means the air resistance is acting downwards, which means the direction of motion must be upwards. So if we look at the marks, so look, first of all, we got 147, mark for Newton's second law, that's what N2L means, mark for 177, the last one was 177 again. Then you get a mark for letting air resistance be R upwards or downwards or whatever. Newton's second law gives us this equation, we just had it going the other way around, and they got minus 15.5. So because they'd set R as going upwards, that means the package must mean R must be going downwards. So we just made a good guess to start with. Okay.